All right, this is the third lesson for set theory for Math 30-2. And just to add on, if you just Google like funny Venn diagrams, oh my God, there's so many, they're wonderful. So this one, I laughed at the hardest. It says, when you say it's fine versus when it's actually fine. And there's only a small intersection. So, haha, good times. So this one is called intersections and unions. So it's really just adding on to what we had yesterday, just with a little bit of notation associated with it. So at the top, sorry, I guess I'm missing some of this stuff from my notes. It says the word and in mathematics means the intersection of sets. So the word and is talking about the intersection of sets and is the elements that occur in both sets. So that is the elements that are in A and also in B. The word or, the word or means the union of sets and is all of the elements in, I'm just trying to think about how I can move this. The word or, means the union of all sets and is all of the elements in the sets. So one set, the other set, or also the intersection, so the in-between part as well. Let's do green now. So the next part, it says new. And or are called operators and have their own notation. So it says consider the set A and B. So the intersection, again, is set A and B and is given the notation. So it looks like this. So it'll be A, and then I really can't, oh, I guess it has it below so you can kind of see it. It looks like kind of an N. It's kind of like a upside down U, but it's a little bit fatter than it should be. So A intersection B, whereas the union, this is again under that part that says new, the union of two sets is the set A or B. And the way that we actually write that is A, and then we turn the symbol upside down. So the way that I always kind of think about it, this one makes sense. Union starts with a U. The one that has an N, intersection. But I guess this one's the more important to kind of, if you're trying to remember it, union there. So these operators can be graphically represented in Venn diagrams. So shade each Venn diagram to represent the statement above it. Sorry, I don't know why this isn't in my slides. So the first one is A, and again, this is the union of A and B. So A, B. So if we wanted to shade this set, this is the union of A and B, we would shade all of it. The next one is A, the intersection of A and B. That one is this guy. So again, the intersection is what's in common or what is within both. And so the next one, you got to think about these. They're going to get more and more complex. So not A. So what that's saying, not the intersection of A and B. So if you look back at the last one, we said this is the intersection of A and B. So if we're saying not that, that's the only part that's not actually going to be shaded. So it is going to be the rest of the circles, but also the rest of your universal set. So the only thing that's not shaded is your intersection is not shaded. So that's not the intersection of A and B. Okay, so then it goes on to here. So it says consider the following two sets. So we have set F and we have set G. So set F is the factors of 24. So we know the factors of 24. You can write them in whatever order you want. 1 is a factor of 24, 2 is a factor, 3 is a factor, 4 is a factor, 6, 8, 12, and 24. Those are all factors of 24. They're all wholly divisible, or 24 is wholly divisible by them. Factors of 30s. So what multiplies by something to equal 30? 1, 2, 3, 5, 6, 10, 15, and 30 are all factors of 30. So it says determine the elements in each of the sets F and G. Okay, so that's what we did up here. Create a Venn diagram for the sets. So we'll do it over here. So I'm going to call my blue one F, this one G. So what we need to look for is look for things that are in common. So 1 is a factor of both 24 and 30. 2 is a factor of both 24 and 30. 3 is a factor of both 24 and 30. 6 is a factor of both 24 and 30. Nothing else, but we can put those again in our intersection. So in that middle part. So 1, 2, 3, and 6 are all elements that are in the intersection of F and G. And then again, our blue circle representing F. Anything that we haven't represented here, we need to represent. So 4, 8, 12, and 24. And in this kind of tan color is anything that we haven't represented. So 5, 10, 15, and 30. So it says determine the union of F and G. So again, this is union. It's talking about the or. So the union is everything. So the union and F, oh, sorry, I made that a U. Should be the union symbol. Is the set 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 24, and 30. So those are numbers that are in set F or set G. And D is asking for the intersection. So again, intersection is the and. So the intersection being this portion here. So the intersection of F and G is the set 1, 2, 3, and 6. I don't know what, it doesn't tell us. It doesn't tell us what our universal set is or anything, so I wouldn't ask you questions like, what's not an F? Because you don't know what would be kind of in that orange box. Maybe it's whole numbers less than 30 or something like that, but I didn't give you that piece of information, so I wouldn't ask you about that. So given two standard die, consider the following events. So this is two 6-sided dice. And we want to look at the following events. So D is rolling doubles. So when you roll it, you get 2 2s or 2 6s or something like that. And S is getting a sum of 7. So on one die, you get a 1, and on the other die, you get a 6 or something like that. So determine the elements in each of the sets D and S. I'm never going to be able to fit this properly. So set D, again, is rolling doubles. So the way that you can get doubles is you can roll a 1 and a 1. Another way to get doubles is you could, these are brackets and commas, it's hard to see. The other way that you can get doubles is you can roll a 2 and a 2. Another way that you can get doubles, you can roll a 3 and a 3. Or you can roll a 4 and a 4. Or a 5 and a 5. Or a 6 and a 6. And for S, set S, again, it's getting a sum of 7. So on the first die, you could get a 1. On the second die, you'd have to get a 6. Or if we think that maybe these die are different and we can tell like one's a blue die and one's a green die, we could have the opposite. So we could roll a 6 and a 1. If on our first die we get a 1 versus on our first die if we get a 6, those are two different processes. Whereas rolling a 1 on the blue and a 1 on the green is the same as rolling a 1 on the green and the 1 on the blue. So that's why we don't write this twice. It's the same situation. We could roll a 5 and a 2 or a 2 and a 5. We could roll a 4 and a 3 or a 3 and a 4. Oops, didn't close that second bracket. So create a Venn diagram for the sets. So I'm not going to be able to smoosh it all in here, but if we call this our doubles and this our sum of 7, so we could roll a 1 and a 1, or 2, oh, sorry, 2 and a 2, or a 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. And for our S, what you'll see is there's nothing in common. So there's no way to roll doubles and roll a sum of 7. So there's nothing right now in that intersection. So 1 and a 6, or a 6 and a 1, a 5 and a 2, or a 2 and a 5, and 3 and a 4, or a 4 and a 3. But there's nothing that's in common for them. So the union, this is the union. Again, you got to be able to remember which is which. The union of set D and set S is anything that's up there right now within these two circles. So you could, I don't know how you want to organize this. You could roll a 1 and a 1, or you could roll a 1 and a 6, or you could roll a 6 and a 1, or you could roll a 2 and a 2, or you could roll a 3 and a 3, da 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 da. So I'm not going to write it all out because I will run out of room. But what you have in total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different, whoa. Ooh, it can read my writing, kind of, not quite. Um, so you'd have, what did I say, 12 different things there. Oh no, now it's doing this too. There we go. So there's 12 elements, I think I said, within the union of those. Whereas this one, so this is saying the intersection. That's again our and. If we look at it, the intersection actually gives us what we call the empty set, that we would draw our fancy brackets, and there's nothing inside of it. You could also write it as the intersection of DNS is what's called the null set. I didn't really draw that right. That line should have gone through the circle, the null set or the empty set. So you draw a 0 with kind of a slash through it to indicate that there is nothing within that set. There's nothing in this portion. There's nothing in there. So when two sets have no intersection, they are said to be what's called mutually exclusive. And we'll look at that when we're in permutations and combinations, which we will do as our next unit. And since they are mutually exclusive, meaning things can only be one or the other, they can't be both, which will result in the empty set. Sometimes you'll see it as the null set. Sorry. That was bad. I'm sorry if that was loud. And can be written as just fancy brackets with nothing inside of it, or that 0 with a slash through it. I need to drink something, I'm dying. So a survey of 34 students, this is our last question, showed that 14 students eat breakfast, 16 students eat lunch, and 4 students eat breakfast and lunch. So the number of students who eat breakfast or lunch, so we see lots of things, ands, ors, not, lots of different things. So it's pretty hard with these ones to try and manipulate everything in your head. So I would recommend just drawing a Venn diagram for it. So here, I'm going to call that B for breakfast, L for lunch. Probably going to start when you're trying to organize this. So we know that our universal set is going to be 34 students. So 14 students eat breakfast. That means this circle, if you're following my cursor there, hopefully you can see it. This circle should represent 14 students. This circle should represent 16 students. But where you're probably going to start is the intersection. It says 4 students eat breakfast and lunch. So we know that 4 students do both of those things. And now we can work outwards from there. So 14 students eat breakfast. Do these students eat breakfast? Yes, they also eat lunch, but they definitely eat breakfast. So we know that we need to subtract 14, subtract 4, gives us 10 students that only eat breakfast. They don't have time for lunch in the day, or they don't have lunch. 16 students eat lunch. Do these students eat lunch? Yes, they do. They also eat breakfast. So 16 subtract 4 is going to give me 12 students that eat only lunch. They get up too late. They don't have lunch at home, or they don't have breakfast at home, so they only eat lunch that day. So the number of students who eat breakfast or lunch, so again the word or, is talking about the union. So what we want to do is add all of those numbers together. So 10 students that just eat breakfast, 4 students that eat both, and 12 students that eat only lunch is going to get us to 26 students. The number of students who do not eat breakfast or lunch. So what we need to look for that, so not in the union of B, set B, or set L. So students that don't have breakfast or lunch, so maybe they only eat dinner. So we'd have to go 34, and we could just subtract this 26. It's pretty straightforward because we know that all of those circles, everything encompasses 26 of the students. So 8 students do not have breakfast or lunch. And so that's it. That's the lesson. So again, working through the questions, double check with my key though. There are some, they're not like trying to trick you, but you just need to make sure you're thinking about these questions in the right way. So your questions are the next kind of 2 pages of notes. So drawing Venn diagrams, figuring out what the question's asking, use those highlighters, use all that stuff that you need. And there will be one more lesson, so applications of set theory. Looking at just a little bit more word problems. I'll probably record that right away as well. All right, have a good one, guys.